but we call it 2 because it's a hexadecimal 2. And we're here with Mark. We're not going to start quite yet. We're going to give it a couple more minutes for people to join. So we're just going to banter. Anyways, Mark was talking to us about how he's looking out towards the bay and is going to get into hydrofoiling and swimming with whales. No, probably not.
Maybe if my wife had her choice, swimming with whales would be like #1 thing we do as a.
Oh, seriously.
Okay, yeah, that's her, like, one of her goals in life is to go swim close to whales. But yeah, it's a beautiful. We live in Bellingham Bay, close to here. It's a little. I can almost see Canada. We're almost to Canada, but we're still in the U.S.
Nice. My wife got a gift card for windsurfing.
Oh, sweet!
We got that like when it wasn't in season, and then we started the process of having a kid, and then so now we're not windsurfing for a while. So
yeah.
Anyways.
So we also have a kid that is 7 months old now, just 7.5 months old, and yeah, I have a garage full of bikes, and I've been on them maybe once in the past 6 months. So.
You know, I think this weekend is the weekend that I buy a kid seat for the bike, mount it on the bike, and then I can go to the beach.
I got overly ambitious and I bought one, and
you already did.
I did, but I got one of the ones that goes in the front, not behind your seat, but in front of your seat, and
yep.
We tried taking it out.
Dude, your legs are gonna hit that immediately.
Yes, I did not know this.
You did. You have to have like a big cruiser bike to I think use one of those.
I thought it would work, but it did not.
Yeah. Yeah, we're gonna get. I think I'm just gonna, buy the one that goes in the back. Daycare's on spring break next week, and so I think I'm taking care of Greta full time. It should be honestly, I guess, a fun time, but I'm also working mornings and evenings, so we'll see how that goes.
I'm sure it'll be a lot of work. Yeah, but it should be fun.
It should be a lot of fun because I don't get to be out in the city when it's sun. My days are spent indoors.
Yes, you get the foggy, cold San Francisco, not the sunny, nice San Francisco.
Exactly. Anyways, enough about kids. Let's talk about older firmware engineers. Welcome. This is Interrupt Live. I'm here with Mark. I used to work with Mark back during the days of Fitbit, when we were both firmware engineers. We are excited to have him here. He had written an interrupt post, kind of about a board checklist. Everything you should verify with your electrical engineer that is, I guess, valid and functional, and to make the firmware lives, everyone's lives, but particularly, Mark's firmware lives easier. It's like dev board and making sure you have JTAG at all times. Anyways, we're not going to talk too much about the article because I think Mark has now, talked about that quite a bit. We're going to talk about other things a little bit past electrical verification. But anyways, I wanted to give Mark a chance to introduce yourself. Mark, you can introduce yourself now. And then what aspect of firmware engineering do you like most today?
Yeah, thanks, Tyler. I've been looking forward to this talk for the past few weeks. It's always fun to talk about firmware. As Tyler said, I'm a firmware engineer. I currently work at a company called Chromatic, which is a company based in New York. I can't talk too much about the product. I'll just leave it with it's pretty exciting, and it has some really interesting tech inside of it. I'm looking forward to it. We can't talk about it publicly, but I can't right now. But as Tyler said, the blog post that I wrote was about. It was actually I have a brother who is also a firmware engineer, and he at one point mentioned hey, we should have there should be a firmware checklist. Firmware engineers across the industry have complaints about the electrical schematics, and when they come together and I can't believe that we forgot about X or Y. And it's actually a long list. It's easy to forget small things that you don't remember until the boards show up, and it's pretty expensive to ship a board, turn a board around, especially if you're depending on which phase you are in the life cycle of the product development. So wrote the checklist, gave a talk about it, and then wrote a blog post about it. I think, as Tyler said, I've talked about it a lot.
We also tried to get you to write that blog post for a year.
Yeah, I did. Yeah, you did try to get me to write the blog post for a year, and I think that was pre-kid, so I don't even have the excuse of I was busy. But I did eventually write the blog post. but yeah, I'm excited to talk about other things. Talk about other things going forward. I'd love to talk about like firmware quality and like how do you get a product out the door that works really well. So I think it's something that's very difficult to do on the firmware side.
Yeah. I guess I have one quick question. Did you provide that checklist to the company you're currently at? Or did they already know about it?
I didn't. And at the point of product development we are in right now, it's not as necessary. But we did have like one small board spin, and it would have caught something that there was a mistake, and it wasn't a big deal. Like it was actually fairly quick turnaround. Yeah. But I was just laughing like, man, I should have just gone through. It would have taken like 10 minutes just to go through this. We would have caught it.
Exactly.
So.
I mean, only one mistake out of the checklist is pretty good, though. I don't know. Like your checklist is pretty exhaustive. So.
Yes.
So as Mark kind of alluded to, we wanted to talk about firmware quality. This is something that honestly Mark and I spent a lot of time together working on at Fitbit. We were both on different projects. I was working on kind of the smartwatch platform, and Mark was on the tracker. What do we call that?
Fitness bands, maybe. I don't remember.
Yeah. Fitness bands. You were on that project, and you were pushing a lot of initiatives there. And so Mark has a lot of experience, kind of working on, a product that has shipped millions, but from end to end. And I think Fitbit tried to do everything with test automation, and testing and tons of QA. And then you honestly get to test the watch on a bunch of wrists to collect some metrics back to see if the things are working correctly. So you know quite a bit. And so, yeah, Mark, I guess the first question I want to ask you is, what are some of the major aspects of firmware quality that I guess you are excited about, that you push, that you always kind of, encourage everyone else to think about?
Yeah, I think most people, when they think, and this is true for me too. Like you think I want to release a great product. Like how do I release a great product that works really well? And like I need more testing. Like that's sort of like the default lever to pull. Like I need more testing. I need hill testing, like some sort of automated hardware in the loop testing. Maybe I need some manual testing. Maybe we need more unit testing. Like I find people sort of reach that lever very quickly to pull. And I don't think that's a bad thing. I think like those are useful things. You should build that. But usually you're trying to get a product out the door under some timeline, and you can't just spend all your time doing testing.
Gets thrown away. It's the first thing to go.
Exactly. It's like, well, we can get a product this coming week, or we can get a product next year, but we'll have this amazing hill test. Those aren't quite. That's probably a bit of a stretch there. But I think there are other parts that go into firmware quality, and I have sort of I'm going to call this a poor analogy to more of the hardware side of like a product integrity team, or a team that has like you have reliability engineering, you have field quality engineering, you have people that are thinking about how's this product going to be used and just testing those parts of it, and you have that through the whole life cycle of the product, from design through like your product development cycle, through all your whole product development cycle, and then even post-launch, right? You still have people that are looking at failures in the field, finding out what's happening, and then you can make decisions on maybe your next product has something that's fixed, or you can make a change to your current, like you can slip a change into your manufacturing line to prevent this issue from happening going forward. And not suggesting that firmware teams go and hire a bunch more people to go solve this problem. I don't think that's why I say it's kind of a poor analogy. I don't know if the same structure works, but I think that mentality of firmware quality from the software design portion at the beginning and hardware design, right? Firmware's always straddling that line, through any testing, like what testing you're going to do to like give yourself confidence that you're going to ship a product you can be proud of, through your release process. How do I know every time I make a change, then I ship that change that I didn't have any regressions? And then to like all the way to user feedback. Like how do you get the feedback from the user that your product is working well and is useful? Because I think that's like a lot of times we miss that. Like, works great on my wrist, works great in my hand, works great in my whatever. My bike, I used to work on bikes a lot. Right?
One though.
Yeah, exactly. And then people say like, well, it didn't work here. And so I think when people think about quality, we think about testing too much, and I think we should broaden it a little bit to think about the full process end to end.
Mark, I'll admit I have never realized that I would argue that hardware engineers have more of a full life cycle standard for like testing quality. Like at Pebble, I think the hardware engineers would always tell me it's like, take your watch in a hot tub, climb a mountain, like go skiing with it, like really like mash on the buttons, like do everything with it. And that was even like a few months after launch because they want to know like what's gonna fail first, because they always have a respin and they can always like change the materials on the manufacturing line. But I think a lot of firmware engineers don't believe that. I guess my question to you is, do you think firmware rots, or do you think hardware eventually degrades? Do you think firmware degrades to where like post-launch firmware engineers are actually necessary? And I think it's a loaded question in some ways. But.
Yeah. No, never. Firmware is perfect. No, I think it really depends. It depends on your product or your team. I think if you launch a product, usually most of the time there's sort of this sprint to get a product out the door, right? You're like pushing things in. Firmware, we have this usually not all the time depending on your product, but if you've built in over-the-air updates, so you actually have till the day the device shows up in your hands to make changes, and that's both powerful and terrifying. Mm-hmm. And then you have this question of like, okay, that day the device shows up in users' hands, and users here being a very broad term, maybe it's consumers, maybe you're selling to another business, maybe you're operating the hardware yourself, but somebody is using your product. But that's what makes firmware engineering fun, is that you actually have a product that people use. And when they start using that product, how do you know that it's going to work well? And to sort of to your question about like, do things degrade? I think that I bring this up because specifically that question, like how do you know it's going to work well, is your key question for how do you know it's degrade or not. Like if you have to spend a lot of time testing up front for that first release in a way that you cannot do for previous like future releases, it's just too expensive for all the testing you put in, I would argue like, yeah, it likely will degrade. But if you put in other things in your system that can say like, I don't have to test all these things because I can actually monitor these things in the field and I can see degradations as they happen. Or like I have a really great automated upfront test suite, or like my product is just so simple, it's very difficult for degradation to happen. Like we don't actually have a ton of features. We've sort of designed failures out of the product. Those are ways that you can keep your, like, instead of firmware rotting, we have an ability as firmware engineers, and as like, because this is the software side of the firmware part, is like we can make things better, and that should be our goal. Like users should have a better experience after each firmware update rather than a worse experience after each firmware update.
Yeah, my experience with this is day one firmware works pretty well because QA has been done, testing has been done as the device is out in the field. We have new Android phones that pop up. We have router updates that get pushed out. The flash chip gets slower and slower and slower.
Yeah. Updates get bigger and bigger and take more time.
Totally, yeah. The watchdog trips on a lot of things because everything gets a little slower as well.
Yep.
And you can't possibly test for those things as well. So like when you go back to firmware quality, like what are the most important things to make sure that your product lasts the 2-year warranty that you actually put on the box? Because you can't test it for 2 years because you're trying to get a product out the door in a year. So like what are some of the things that you would recommend? Yeah,
great question. I think like two of the things you brought up just there are things that I'm sure you've run into. I've literally run into too. Of like, hey, we had the firmware update process. It worked great, and then our firmware update got 100 bytes larger, and it turns out that like our signature verification, the firmware update was longer than the watchdog timeout, and so like we cannot update from older versions. From like there's a jump firmware that you have to go through now if you're on older versions to go to newer versions. So I think to answer the question, like what things do you think about it? I think I would think about it in two ways. Like, thing one is like what are the known failures, and this goes back actually similar to that checklist concept of like as an industry, you and I just had two things that came up that timeouts on watchdogs and networking changes that are outside of your control.
Everyone has those.
Yeah, like those happen all the time. Like, how do you so two ways you can deal with that. One is purposely make all your flash operations take the maximum time they can take. right? Like so that you can never actually run into it. Like look at the data sheet. How long does the flash operation take? You can sort of design that failure out of your product, saying, hey, like as long as everything's within like max time of the data sheet, it never gets slow. It never gets slower than this. Make your firmware update maximum size every time, even if it's just padded with zeros at the end. So that like, your firmware update is almost always. I guess I am biased here. When I say firmware, I usually mean like 32-bit RISC devices or Cortex devices. That's the world that I live in. But so in my world, you're usually limited on the firmware. Like your firmware update can only be X amount of size. It cannot be any bigger because you run out of space. And so like one thing you can do is just make your firmware that size. I think that's path one. And path two is like when these things inevitably happen, what is your fallback mechanism? How do you design in an extra sort of path in your normal procedures to fix these sort of things? And for, like on networking issues, like one thing previously I was working on bikes and scooters and worked on bike share, and we could do things like every bike or scooter has to be updated via two ways. Like the cheap fast way, which is over the air. We have an LTE connection. We can download a firmware device, download a firmware in that system in our cloud. We could target and say, if you're on this version, you have to go through a certain version first before you go to the next one. So we could. It wasn't fun. We didn't like doing that, but we could sort of build in jump firmwares into our design and sort of fire and forget. And then if everything went horribly wrong, we could also plug the device in and update over a hardwire. So that like if we say pick your network provider, say Verizon. If Verizon changed something, right, and
all your scooters went offline.
All your scooters go offline, right? Like
you could still recover them. It'd be expensive.
Yeah, exactly. And we were by the time I left that company, we were large enough that we could probably have a conversation with them and say, like, hey, but when we started, if we said, hey, this is a problem for us, they're gonna go like, too bad, but that's not our problem. So actually, when we first shipped, we just had the ability to open up the lid of a device, plug in JTAG, and flash it. And actually, for the first month of operations, every night we just go collect all the scooters, and bring them back to the warehouse, plug in JTAG every one of them, flash them, and then go deploy them. And that was our firmware update strategy to start with. And it was expensive, but it was the right business trade-off at the time.
Yeah, always. So the key there is always think about the fallback case. And then, we had talked briefly about like getting the device to send data back so that you know what's going wrong. That is, I would argue, very rarely something people design into their product.
Yeah, I
like
think
collecting user feedback. I want you to talk more about that.
Yeah, I feel like you're a little biased for the company that you work at, but
totally. But also, we had that built. We had that. It was such a core part of Pebble. Like if people couldn't have sent us feedback or bug reports.
Yeah.
I never fixed any bugs ever.
I'm very supportive of this concept. Like, I think one thing that we like when we were working on the bikes and scooters at Lyft, we had an LTE connection. Or like we had the easiest way. We could choose when to firmware update. We own all the devices. We can choose when to firmware update them. No user can tell us don't firmware update them. Like we own them, so we can choose. And we have an LTE connection. Like we can send data back, and we actually had a fairly cheap like LTE partner. Like our cost per megabyte was fairly cheap, and we could throw everything in S3. So we sent terabytes of data back. Like we sent tons of data back, and that enabled us to do really powerful things on firmware update, where we got to the point where we could detect less than a 1% regression in sort of key metrics like number of rides per day. Like we could do a firmware update and we could detect less than a 1% regression in that rollout. Because we'd roll out over a week and we had all this data and we could build it as an A/B test. And like, if you think about the amount of money you would have to spend to get hill testing or especially manual testing, but even hill testing into a point where you can detect like a 1%, like a less than 1% bug, it's pretty enormous the amount of money you have to spend. But if you can collect all the data and do it do it that way, you can actually detect these regressions. And I got accused at one point of having your users test your product as opposed to testing it internally.
Exactly what I love to do that. You don't have to like change the feature, but at least like measure, calculate things in a different way, and then send both of the data pieces back. And then you can compare and contrast before you actually change the feature. I don't know if you want to change an algorithm, like think we did that at Pebble, actually, potentially at Pebble. But we would just like not present the user with a different step change algorithm, but like send both data points back and see if it's actually more accurate or not.
Exactly. It enables exactly that. And even my argument for that is this testing, the level of testing that we're doing is far better than anything that we're going to do in-house, right? Like again, it's just that the amount of investment that it takes. Writing hardware in the loop tests is great, but it requires a pretty expensive team, right? You have to have somebody that can both build a sort of firmware API that a firmware engineer can use to like build automated tests, and build hardware infrastructure to set this test up such that you can physically automate button presses or whatever you're trying to automate, and then you need to have someone that is maintaining that sort of like that's their job. And so you end up hiring the whole team. And if your firmware team is already only like 3 or 4 people, you're doubling the size of your team, doubling the cost of that team to set up this test. And I think sometimes in some cases this makes a lot of sense. We also when we also work in bikes, we also own battery firmware. Right? Battery firmware is a safety component, and a pretty big safety component. I'm very proud of the job that we did on the batteries, but we did invest and we did do the whole do a full battery simulation with the tester, and we had one person whose job it was. One person that set it up, and then one person whose job it was just to maintain and run that hill tester. And that was a cost I'd be happy to pay, and happy to pay again. But when you don't have that safety critical component, it's hard to justify that cost.
Yeah, that's amazing. Okay, I have a couple more questions, and then I think that's about all the time we have, unfortunately. When you have LTE connections, or even not even that, when you have a data flow back from customers or devices where they can send either feedback or they can basically report a bug or capture some data from the device and say like, hey, something's not acting right. Like, what does that enable? How does your behavior as a firmware engineer change?
I think like one of the things you brought up about Pebble is I think is a really powerful one. Is like, I think that maybe I'll just walk through a scenario. You get a bug report. I'm sure most firmware engineers are very, very familiar with this. You get a bug report and you don't really know what's happening, right? You can't reproduce it at your desk. You walk through your code. There's like, there's like 20 things in the code that could happen that would trigger this behavior. Which of these 20 things is happening? And if you don't have that ability to get feedback, this means your feedback loop, because somebody told you that you have this bug, right? So your feedback loop is admitted to customers. Customers report you have this bug, and maybe you only had a few people report it. You have to just fix them sort of one by one, or maybe you sort of binary search through those things, and hopefully you were right with those 20 things. Hopefully you didn't miss it. It was something else. It was just a Stack Overflow somewhere else. But once you have this sort of feedback mechanism, you're like, okay, here's 20 places in the code that these things would happen. Let me put a counter in each of these 20 places that will show if this thing ever happens. Or even better, in my opinion, just if these things shouldn't happen, just assert in all 20 places. And then test it, go through your normal release process, make sure that it's good, the product still works as it's expected to work. For you, maybe you do it for like a small beta test. And then whatever your release process is, to give you confidence that you're shipping a product that you can be happy about. And then you release it and you say, okay, which of these things are crashing? And maybe you're like, wow, none of these things are crashing. That's not the issue. Or maybe it's, this counter is going up. Whatever it is, that is such a powerful tool to solve these bugs that you can't reproduce. You just can't possibly reproduce at your desk. I don't know how else you could really solve that for a similar cost trade-off. Let's put it that way.
Yeah.
You could, if you spend enough money, you can do whatever you want. But for a similar cost trade-off, I don't know how else you could do that.
I love the idea of putting counters pretty much everywhere, because I guess they're cheap. It's usually just like a couple bytes here and there to send the data back, and it's also like how you understand, is this bug happening? I know people like to compile out asserts. If you do it, at least add counters. At least add counters or logs and actually collect those counters and logs. But yeah, don't compile out your asserts. It's a no-no in my belief.
Yeah, I think I've seen a few blog posts come up from Menfold about offensive programming, and I feel like this is part of that. It's like, leave your asserts in, crash. Make sure you can have visibility when your asserts happen. Like, this is part of that. Like, if you don't have visibility once your asserts happen, I would still argue you should leave the asserts in. Yeah. But like that's a much harder argument to make. But build observability into that. Use a product like Memfault to help. I mean, Memfault, I think, is, I'll just plug you guys here because I love your product, which is like, there's no other product in the world that will give you a backtrace like you can get with Memfault. And you will never build that internally. But that is a super powerful thing to help you understand, like, okay, if I just put in a cert here, even if I have no other visibility, if I put in a cert here, I can at least know if this is happening. And I don't have to write the if condition here, like if this failure happens, if I
It's so easy,
stops
one
responding
line every time.
Yeah, like if I2C stops responding, like what do you really do? Like there's not a lot of options. Sure, there are things you can do, but then if you have to do that in every place that you put the assert, like, okay, how do I recover from this condition and this condition and this condition? Your code base becomes huge, and you've never tested any of those code paths. Just put an assert in. Yeah.
Just reset, basically.
Just reset.
Behavior.
Yeah,
Okay,
or go to a safe state. Yeah.
We are over time, and I'm gonna blast through the rules. I don't care. I have one more question because it was my favorite comment in our walkthrough before this. You had advocated for shipping more quickly because you'll have less bugs. Please tell me more. Yeah, you have a minute.
Okay, it's a counterintuitive idea because I think it's very easy to, like, oh, we had a release and we broke things and it gets really scary. Like, I don't want to do that again. And I get that. I've been there. I still experience that. When you delay your release, if you have not improved your testing in between your release process testing, delaying your release just means that you get your test results, your data from the field, back slower. So for every, like, if you look at the number of commits that have changed since the previous release, every commit can have a bug, and every commit interacting with another commit can have a bug. And if you're only testing, like, and that increases exponentially, right? As you, like, one with two, like if you have two commits,
yes.
Every combination of commits can increase a bug, and which makes it difficult to root cause what happened. If I only have one change and I make a release and I have some sort of regression, it's very clear, like, it came from that one change. Or even if it wasn't the one change's fault, like, that one change caused that issue. But if I have 10 things, any one of those 10 things can cause it, and then it's like, I don't know if it's like 10 factorial or what exactly the combination math is here, but it's something like that. It's going to say, here are the number of combinations of interactions that can cause this issue, and I find that you usually end up with just like a slow release process that is just painful every time, versus shipping more often, testing less things. It's a very common idea, like server backend software side, and I think it also applies to a firmware team that is shipping often.
It's terrifying, but yeah, if you have the system in place to collect the data from the device, to know as soon as it fails, basically. I mean, one, you're probably going to catch a lot of these in internal testing anyways, because you have the data collected automatically. Like, but yeah, like shipping every week, you're probably only committing 10 times or 20 times, and it's going to be one of those 20 things. Yeah. And if you ship every 6 months, you're going to have hundreds.
Yeah, exactly.
Hundreds of things, and you have no idea where to look where that bug was introduced.
Exactly. And you don't remember, like, it's been 6 months since I touched this. Like, who remembers what I was working on? Yes.
All right. Anyways, thank you so much, Mark. This was great. I love the chat. Yeah, we try to cap these and make the videos at least digestible.
Perfect. Yeah, thanks, Tyler. Appreciate it. Love being here.
And thanks for joining us for Interrupt Live. We'll see you next time. We got to figure out who we're chatting to, but we'll let you all know soon. Again, thanks, Mark. Enjoy swimming with whales. I know you're probably not going to do that today. But
I'll do. We will. At some point, we will.
All right. Bye.
Bye.